Hi, so this is a rather expensive flame effect convection fire, and it belongs to a viewer called Clive. I got an email off Clive's daughter, and what she said was that her dad's just turning 90 and the fire was deemed not repairable because there's a fault with the circuit board here. So we'll just plug it in, we'll just switch it on and see what it does. It's also got a remote control, and it's absolutely dead as a doornail. So this apparently needs a replacement control board, which they aren't available because the fire has been discontinued. So whether or not we'll be able to repair it or not, I do not know, but we shall see what we can do. So I think I'm going to spin it around so the board's more over this side, and then it's going to be easier for me to work on, I think. So to access the board, it looks like we need to remove these screws here and possibly these ones here. So I'm going to do that. And I'll just bring a picture up of the fire, what it looks like when it's all together with its nice brass surround and everything. And when I've had a look online, they seem to retail for around about £600 or so. So quite expensive for what's basically a glorified heater. Right, a couple of more screws and then we're into it. So this looks like the problem board down here. So it's quite dusty. So what I might do is see if I can get these PCB mounts out of the way. And then I'll take a photo of it so we can see where all the wires go, I think. Right, I think that should be the board free. Right, let's just try and zoom down a little bit on this. I can't really see anything. Looks like we've got a little power supply here, a little switch and IC power supply, up to isolator for feedback. These must be the 3 relays that control the fire's different functions. We have a connector here that looks like that goes off towards the power switch. And this is the back of the board. Looks like we've got a microcontroller there. And those circuits there look quite familiar. I think I've came across something like that. I think it was the Kitchen Boss sous vide cooker. And what that little circuit does, if I remember right, is if the MCU crashes, it means one of its I/O pins would be in sort of a set state, either high or low. And for this, what this little circuit does there, you've actually got to keep toggling the I/O pin between the high and low state at a certain frequency. Otherwise, this transistor turns off and shuts the relay off. So if the MCU crashes, it means the pin isn't toggling, so everything switches off, which I thought was quite a clever design. Now, I don't know whether to try and get this board out, just so we've got a bit more room on it. I'll probably have to mark these connections up, so I shall just go and do that. Well, a slight change of plan, because what I've managed to do is cut a bit of cardboard and cut the cable ties, so I've managed to stretch the wires a bit so I can test some voltages on the board while it's actually all connected. So I'm just about to plug it in. I'll just get the meter there. Let's see if we can get that to go there or something. And what I want to try and do, there's a capacitor here. I want to try and measure the voltage on here. And there's another one over here. Because I just want to try and determine if there's a fault on the power supply or if it's a problem with the microcontroller section. So if we measure the capacitor here and it's got voltage on it, that means that the power supply is okay. And the problem's going to be over here. So let's switch it on. So that's it on there now. Check my test leads, and I'm on volts DC. Well, we don't appear to be getting anything there. I'm just being careful not to electrocute myself yet. And we don't have any, oh we do. 1.2. That seems very low. I'll just try this capacitor again. And nothing. So this seems to be some kind of power supply issue. Let's see where the mains cap is. I'll just switch this off a second. It looks like we have a mains cap just here. So let's see what we're getting on that. Right, it's back on again. Wouldn't appear to be getting anything on that. Right, I'm just going to switch this off again then and see where the bridge rectifier is. Actually, I can't even see a bridge rectifier on this. Now I am confused, because this is the filtering section here. Well, now I am confused with this. I'll just check that it's switched off still. Right, let's see if we get AC to these 2 points then. I think that's going to be the next thing to try. Right, I'm just going to switch it on now. And we've only got about 5.5 volts AC there. Alright, hold on then. So we've got power there. But not there. Interesting. Right. I'll just switch that off. Because we have a little inductor here. I wonder if the inductor's gone open circuit or something. Because we're getting AC on this side of it, but not on that side. Let's take, actually we should be to just measure, I'll just unplug this. And let's measure the resistance between, right, so we've got mega ohms on that one. And about 1.9 ohms on that one. So it looks like that inductor from there to there has gone open circuit. Well, that's unusual, I don't think I've had that before. I'll pull this inductor out and then we'll have a look at it. I'm just going to add some fresh solder to it first. Ah. Has that gone just there? Yes, I think it has. Yeah, there's no wire there. The wire stops just there. You can see the wires going on this side. But the wire's broken just there. And you can just see where I've just cleaned the end of it. I should have one of these on an old power supply somewhere, so I shall go and have a look. So I've found a replacement inductor which I've just fitted. As you can see here, it's a slightly different style, but it'll still be alright. It's just a filter for filtering mains interference. But what I have noticed is there's another component just in front of it here. I don't know if I can zoom down any more on that. Let's try and focus it in. You might be able to see a bit better there. Hold on. Looks like there's a big hole blasted in the side of it. Just there. So I wonder if there's a short or something on this power supply. So I'm going to take this out. We'll have a look at that next, and then we'll see what else we can find. So that other component is just between this diode and the mains. Actually, what I should do is measure the resistance of it first. Let's just try that. You never know, it might be okay, but I don't think it is. So I'm just going to do ohms. Nope, we have meg ohms there. So whatever that is, it seems to be gone as well. Let's see if we can get that out. And it's just fell out. It's like sort of a wire wound resistor or something. I'll try cleaning it off a bit and then I'll see if I can figure out what it is. Well, I was just trying to clean the board there and it all looks carbonised round here. So I'm going to remove this capacitor, we'll test that in case that's leaked all over the board, and we'll try cleaning the board up with this removed. Right, I'm going to try cleaning this up then and we'll see how we get on. So I've managed to identify this part here. So brown, black, black, gold, and then black. So this is a 10 ohm fusible resistor. And because it's blasted, there must be a short elsewhere. So let's see what else we can find. So this is the capacitor that I've removed. And it's a 1 microfarad 400 volt. So let's just test it with the ASR 70 gold here. Let's try that again. So it's got an ESR of about 34 ohms, which is a little bit high. So I think we'll replace that. And while we're on, we might as well replace that one as well, because that's the same value. It's probably also worth replacing maybe those three as well. And what else I've discovered, I'll just move this meter out of the way. I'll just get this one in shot and we'll just go into diode check. I think the main IC is blown as well. Because if I measure from, I think it's this pin 2. And if I measure across this diode, now that could be because it's in circuit, but I'm pretty sure that the main IC is blown and possibly that diode as well. So I think we're going to have to order a few parts for this. So what I'll do is I'll make a list of parts, I'll order them, and then when they arrive, we'll fit them and hopefully we can get this thing working again. So I just thought I'd remove the IC before I ordered some parts. I'm just trying to get everything assembled on my bench here. So this is where the sense pin, so this is where the power comes in and it gets sent out of the drain pin here. And if we measure between those two, we've got almost a direct short. So this chip is definitely fried. So we need to order one of those. I've actually found a couple of capacitors which I've already fitted. If I check these diodes now, I'm just trying to get these in shot. So it appears that the rest of the components I think are okay. So we're going to need a replacement IC, a fusible resistor, and then possibly another few capacitors, which I should have some lying around in any case. So something else that I've just discovered, there's two current sense resistors here which are 2.2 ohms. Now if I just touch my leads together, you can hear them beep, but if I go into the resistor here, nothing. And the same on this one here. If I go on the 4.7K, you can hear that one's okay, but those two are definitely fried, so we need two of those as well.
1 week later.
It's been just over a week and the new parts have arrived, so I've got new switching ICs, fusible resistors and the 2.2 ohm current resistor. So I'll just go and grab the fire and then we'll fit these and we'll see if we can get it working. So I think we'll fit the two current sense resistors first. So I'm just going to add a bit of flux. I think I'm just going to put a blob of solder on the pads on this side first. Right, I think that should do for that. Let's get the IC fitted now. And that should do for that. So just the fusible resistor to go in here now. I'll just put the resistor in place. So let's just solder that up. I'll just snip off the legs. That's all the new parts fitted to the board now. And hopefully the IC that I got from AliExpress isn't a fake and explodes everywhere. But we shall find out. I'm just going to tuck those wires down there for now. I've got the dim bulb tester here, so we'll just plug it into that. Right, so here goes. Well, it didn't go bang. Well, hey, that was the power button. That would have been the dim bulb tester kicking in there when I switched the heating element on. That's when the relay clicked in, so obviously there wasn't enough current coming through the bulb here, so the power dropped and it tripped the MCU out. So I think this is working. So what I'll do, I'll put the front back on and then we'll give it a proper test just on an extension lead and we'll see if it all works. So you was told this couldn't be fixed because the board was obsolete, so let's see what happens when we switch it on. Well, it looks like the fans are working. All the coals are lit up there. We've got a little flame effect going. So I'll put the thermal camera on. And then we'll just switch it on. And I can feel heat coming out of it. I don't know if you can see there on the thermal camera. There's heat coming out the top there. And that's on the high setting. So I just heard the other relay clicking. So excellent. So I would say this is all working. So a nice little fix on that one then. So I'm sure you'll be very happy with that.